Alright, this is problem 2 of homework 8. So problem 2 gives us the following density function, joint density function. And part A asks us to find the constant A such that this is a valid joint density function. So we have to be very careful because these absolute values can throw in some issues with minus signs. So first, let's just look at this piece here. We have x is less than or equal to absolute value y. So that means y can be greater than or equal to x. Or we can have a minus y greater than or equal to x, which becomes this. So we have these two conditions. Let's draw that. So I have it drawn here. Y greater than or equal to x. Well, x is in between 0 and 1. So we just have this line only in between 0 and 1. And we only care about the region where y is greater than x, so that's this shaded region over here. Now the other part, y less than or equal to negative x. So here's the line minus x, again, only between 0 and 1, because x only exists between 0 and 1. And we only care about the portion where y is less than or equal to minus x, so that's this portion over here. So when finding a, we have to integrate for these two portions. So we know that the density function, if we integrate from negative infinity to infinity, gives us 1. So we start with that. So let's take a out here as a constant. And I'm going to separate this integral into two cases. First case is just going to be x plus y, where y is positive. So absolute value of x plus y is positive, so I don't have to worry about this. And we have dx, dy. That corresponds to which region? To this region, because this is where y is positive. So, actually I want to do y first. Let me do dy, dx. So y goes from x to 1, and x goes from 0 to 1. Plus, now we have to consider the negative region. I took a as common factor for both. So the negative region, that's where this guy could be negative. So now we have to be careful. If this is negative, absolute value of that is going to be minus x plus y. So now we're only integrating over the region where y is negative, which is this region over here. So I'm going to do dy first, then dx. Y goes from negative 1 to negative x, and x goes between 0 and 1. And we close this bracket. So the only problem is we have to be careful with this minus sign. Now let's expand. So this guy integrated with respect to y becomes, we still have the integral with respect to x, then we have x times y between x and 1 plus y squared over 2 between x and 1, and that's, we also have to integrate this, the result of that, x between 0 and 1, plus now we have the other portion between 0 and 1. The minus sign carries through, so we're left with minus xy for y between minus 1 and minus x. And we have minus y squared over 2 between minus 1 and minus x dx. Okay? So now we get a integral 0, 1. This is going to become x times y minus x, so we're going to get x times 1 minus x dx plus, now I'm separating this part and this part into two separate integrals because there are some, so I can do that. This is going to become 1/2 minus x squared over 2 dx plus, now we're going to get, for this piece, we're going to get minus x times minus x plus 1. So you've got to be careful with the minuses. minus, and here we're going to get x squared over 2 minus 1/2. And this is going to be, oh, I forgot my dx here, dx. Okay. All right, so now we have a x distributes, so I'm going to break it further down. So I have just this, and I have minus x squared, like that. And then I have, this is just going to become 1/2 minus, then I have this integral. Right. I'm not going to write it again. I'm just going to evaluate the integral. So it's just going to be x cubed over 3 between 0 and 1 plus, then we have between 0 and 1 we have plus x squared minus x dx minus this part. I'm going to put a bracket here because we have to be careful with the minus signs. This is going to become x cubed over 3, but over 3 times 2, so it becomes 6 between 0 and 1 minus, and this just becomes 1/2 bracket. Okay, I gotta move to another page. All right, so then what do we get? This becomes x squared over 2, so we just get 1/2 minus, this becomes x cubed over 3 between 0 and 1. We have plus 1/2, which carried here, minus this guy, which is x cubed over 3 between 0 and 1. This becomes x, let's see, plus 1/2. Let me see. I think I forgot something. X cubed over 3 plus 1/2 minus, let me see, what did I forget? Let me see in a second. Ah, I see what I did. Okay. Back here. This piece, this becomes 1/2. There's also a 1/2 here that I forgot, so I have 1/2. So this becomes 1/6. I went too fast. You gotta be careful. When you go too fast, you make mistakes. Alright. So this becomes 1/2. We have 1/2 here. This becomes this integration becomes 1/3 times 1/2. So this isn't this. This is minus 1/6. Okay. Plus, then we have, here we have x cubed over 3 between 0 and 1. And here we have minus x squared over 2 between 0 and 1. Minus, here this becomes 1/6. Minus minus 1/2, plus 1/2. And I forgot my a in the front. Continuing on, we have a bracket 1/2 minus, this becomes 1/3 plus 1/2 minus 1/6 plus 1/3, this becomes 1/3 minus 1/2 minus 1/6 plus 1/2. Alright, so we can see here we have this guy cancels with this cancels with this. Anything else cancel out? No. So all we're left with are, we have this guy, this guy, this guy, and this guy. So we have a 1/2 plus 1/2 is 1 minus this plus this, so it's 1 minus 2/6. This is just 1/3. 1 minus that, so 1 is just 3/3. 3/3 minus 1/3 becomes 2/3. So we're left with a times 2/3, and we know that this whole thing equals 1. So a becomes 3/2 in order for this to be a valid density function. So that's part A. Now part B. Part B asks, they say z is equal to x times y. and they want you to find density function of z. So here I use the Jacobian. We have z equals x times y. I said w is equal to y. Now here again we have to be careful. There are two cases. Y is positive and y is negative, and that's because we have an absolute value for y in the original function. So we have to be careful here. So let me rewrite this. So we have z equals, well, I set y to w, so it's xw, and w is equal to y. So the Jacobian of x1, y1 is equal to the determinant of, we have dz dx, right, dz dx, which just becomes y, dz dx becomes y, dz dy becomes x, then we do dw dx, 0, dw dy is 1. And then when we work out the determinant, we have y times 1, which is y, minus 0, just becomes y. Evaluated at x1, y1. Well, y is just w, so this just becomes w. So, what's x1, y1? x1, just solve for x, is going to be z over w. y1 is going to be w. So now, what I'm going to do is I'm going to first consider the positive case. So that's when z is positive. So that means y is positive. Right? Because x is always going to be positive. The only one that could be negative is y. So you have to consider y positive and y negative, which is the same thing as considering when y is positive, z is positive. So we consider z positive, or when y is negative, z is negative. So let's first consider the case where z is positive. Okay. Now we have to be careful. So if we go back here, we know that y, absolute value of y, is in between x and 1. So this is first case. So z positive, which is the same thing as y positive. So we have, what's y? Y is just w. And w is in between 1 and x. But what's x? Z over w. Now we don't have to be concerned about the absolute value because we're only considering the case where y is positive. So let's find the range of w. So we multiply everything by w. We get w squared, w, z. Take square root of everything. Now we don't have to worry about any pluses or minuses because we know that w is positive, so that we know for a fact that we're just going to get this. Okay. So w we also know is less than 1. So w goes between square root of z and 1. This is going to be very important because it's going to help us do the integration. Okay. So using the Jacobian, we can find f of zw, which is just going to be f of xy at x z over w, comma y w, divided by absolute value of w, because that's the Jacobian. So this is the actual function, but we want to find fz of z, so we got to integrate out w. Okay, so I just want to remind again, this is only for the positive case. So fz of z is equal to the integral of fxy. What's fxy? It's just this guy. But we don't care about absolute value because right now we're only considering positive case. A is 3/2. We're dividing by w, so I put the w here. X is z over w plus w. And this is dw. Now we want to integrate out w, but where does w range from? Right here. W ranges from square root of z to 1. So we go from square root of z to 1. And then we carry through the integration. Take out 3/2 because it's a constant. And we're multiply through by w, we get z over w squared plus 1 dw. Square root of z, 1. This equals 3/2 common, the constant. This guy becomes negative z over w between square root of z and 1. Now why is that? Because we're integrating w, so the integral of w to the minus 2 we get a minus 1, minus comes out, and we have to evaluate between these 2 points. 1, and that's going to be just this. So now, what do we have? We have 3 halves, it's a 3, minus z over 1 minus z over square root of z. This becomes a plus. Plus 1 minus square root of z. Here I'm going to multiply top and bottom by square root of z. Square root of z times square root of z becomes z, which cancels with this. And then we have this square root of z is a plus, this is a minus, so this cancels with that. So we're left with 3 halves, 1 minus z. Now this is fz of z, but only for z positive. Now we have to consider the case for z negative. Okay. So, z negative. Now we got to be careful with signs. So that's when y is negative. That, remember we had this here? Well now, absolute value of w when w is negative is actually minus w between these 2 points. Now we multiply everything by minus 1, which switches the signs. Minus z over w minus 1. Multiply by w, get w squared minus z minus w. Note, because w is negative, minus w is positive. Because z is negative, minus z is positive. So what I'm about to do right now, take the square root of everything, I get w, I'm going to come back to this. 1 second. So we have this and this. Now this is not entirely correct. I just want to point out, this is not imaginary because w is negative and there's a minus. This is negative, so minus minus becomes plus, so these are valid. There's no imaginary stuff. However, this part is not totally correct. Why is that? W is a negative number. When I square it, it becomes positive. Now, when I take the square root of this, I should get a positive number because I originally had a positive number. Square root is just going to give me a positive number. However, w we said was negative. So right now this is saying that w is negative. So I got to put a minus sign here so that I get positive w. Because w is negative, this becomes a positive number, which is correct. So now, multiply everything by negative 1, which switches the signs again. And we get this. W, we know, is less than 1. I'm sorry, it's because it's minus, now I gotta be careful. W is less than 0, but greater than minus 1. Because if we come back here, we see y, because w is y, is in between minus 1 and 0. So they're gonna put that down. W is in between, so it's less than 0, but greater than minus 1. Right? So, let's see. Something is, let's see. I think I made a slight error. 1 second. Switch to signs. Let's see. Okay. See, the thing with the minus sign, you can easily make a mistake. Let's see. Minus c. Okay. W is in between minus z. Okay. I did make a mistake. W, because it's negative, it's in this region. Right? So that's between, it's greater than minus 1, but it's less than minus x. minus x, well, x is just z over w. So it's minus x, like this. This is the correct region. Ignore this, this is wrong. So now we do the same thing. We multiply everything by w, but because w is a negative number, we have to switch the signs. So we get minus w minus z. Again, these are positive because z is negative and w is negative, so the minuses take care of that. Then we take the square root, so we're left with this. Now again, this is, I want to explain that. We have minus w. In order for this to be correct, because w is negative, we got to put a minus. And then I multiply everything by minus 1, change the signs, and I get minus, that's better, okay. So right, and w we know is in between 0 and minus 1. So w goes between minus 1 and minus square root of minus z. So this is the range for w negative. Yeah. So sorry about that. The mistake I made was that w, which is y, goes in between minus 1 and x. Well, minus x, I'm sorry. So minus x is minus z over w, and minus 1 is here. So this is the correct region. Okay. So we have fzw is equal to fxy of z over w, comma, y over w. Now, f of z equals, we have integral 3/2. Now we have to be careful with the absolute value. Because we're dealing with the negative case, we have to put a negative in front of these guys. So we have a negative z over w plus w divided by, this w is here, but absolute value of w is just the same thing as w multiplied by minus 1. These minuses cancel, and we have dw. dw goes from minus 1 to minus square root of minus z. Again, this is only for negative, for z negative. Carry out the integration, we get 3/2. This guy, z over w squared, because I multiply the w through, plus 1, dw, minus 1 minus square root of minus z, which equals 3/2 minus z over w, right? Because that's this, oh, I forgot w squared, it should be w squared. That's this integral between minus 1 and minus square root of minus z, minus, well, it's plus this minus this. Well, so it's, right, but this eventually just becomes a minus. So is this minus this? So is this plus this? Because the minuses cancel. Okay, this equals 3/2. Now we have minus z over minus square root of minus z, minus, still a minus z, minus 1, these cancel, minus square root of minus z plus 1, which equals, so let's see, I multiply top and bottom here by square root of minus z. These become minus z, right? Because this times this becomes minus z. This cancels with this. I still have a minus here though, so I have 3/2 minus square root of minus z minus z minus square root of minus z plus 1. This becomes 3/2. These two add together to become minus 2 square root of minus z plus 1. And this is little f of z for z negative. So let's just see, they want you to find, so we found it, now we got to draw it. Okay, so let's just write it down. So fz of z is equal to 3/2 1 minus z for z positive, and then we have 3z this for z negative. Okay, now we got to draw it. So let's draw it. Here we have 1. Here we have 1. That's kind of off center. Whatever. Let me draw a new page. We have 1. We have 1. This is 1/2. 1/2. So 1.5. Negative 0.5 minus 1. Okay. So let's look at z positive. At z equals 0, we get this. I'll make this 1, and I'll make this 1/2, so we get 3/2. And at z equals 1, we get 0. So it's just a line, it's linear from here to here, so it's just a line. And we get this. Now for z negative, we got to be careful. So if I plug in -1, minus times -1 becomes 1. So I have -2. This becomes +1. So we get -2 plus 1 becomes -1. Plus 1 becomes 0. So at -1, we get 0. However, this isn't linear, not a linear function. So let's find at 0, we get just 3/2. We get the same thing. But we want to find something in between. So let's do 1/4, for example. So 1/4 is -1/4. So minus 1/4 becomes just 1/4. Square root is 1/2. This becomes, so if I have 1/2 minus 2 minus -1/4 plus 1. So this becomes -1. This becomes 1/4. This should be a plus. Plus 1. This minus cancels with this minus. And we have, of course, out front, we have a 3/2. 3/2. So we get 3/8. So that should be, let me just check that. Right. This becomes -1. This becomes plus 1/4. These cancel. So you get here, this. Right, so it's something, it's 3/4, which is up here, because this is 1/2, this is 3/4, but it's 3/4 divided by 2, so it's just under 1/2, something like this, and 1/4 is somewhere over here, so it's some point over here, so it kind of looks something like this. Like this. And this is little f of z. So we have here, we have the function. And here we have the figure. And that completes the problem.